Thank you so much, Katie, and really thank you for putting this whole thing together. It really is a privilege to be here talking for this Yellowstone Forever talk, and I get to talk about what I love to do, which is working with fish in the park. So I'm going to dive right into it here and give you a presentation outline. We're going to talk about the different species of our sport fish in the park, starting with cutthroat trout in Yellowstone Lake, so the Yellowstone cutthroat trout, which exists in Yellowstone Lake and also throughout everywhere that's kind of highlighted in yellow here. And so for a while, I'll also discuss the Lamar Valley drainage, which harbors a pretty famous population of Yellowstone cutthroat. Then I'll dive over into the Westslope and Arctic grayling world, which is on the northwest side of Yellowstone National Park, and that's where my work is mostly focused. And I'll end the talk with just an update on our different extension programs, like our Yellowstone fly fishing volunteer program, our aquatic invasive species program, and then just an update on different regulations that have changed in the boating and angling laws. So, without further ado, we'll dive into Yellowstone Lake first. Yellowstone Lake is the largest high elevation lake in North America at 136 square miles and a maximum depth of almost 400 feet. It is immense. It is a really beautiful location. It sounds like this group is going to go there tomorrow. Has anyone been to Yellowstone Lake before? Yeah, it's really beautiful over there, isn't it? So, I highly recommend you get over there, and I'm glad this group's going to go see it. It's home to the largest genetically pure population of Yellowstone cutthroat trout. And this is an iconic species that anglers from all over the world come to fish for, just to get to hold one of these beautiful specimens. It's also a keystone species to the Yellowstone ecosystem. They play a vital role in many mammalian and bird diets. Different species, I think there's like 12 different species that have been documented consuming cutthroat trout. I would like to hear at least 4. Throw me some. What species do you think eat cutthroat?
Grizzly bears?
Yes.
What did you say?
Grizzly bears.
Wolverines.
Well, we don't want lake trout. Okay, let me rephrase this. Native species that eat cutthroat trout.
Do you have ospreys?
Ospreys, yeah. Mm-hmm. Pelicans, yeah. One more.
Bald eagles.
Bald eagles, yeah, great. Additional otters have been documented, black bears in addition to grizzly bears. We had a fox that ate one this spring in Yellowstone Lake. So a lot of different species rely on cutthroat trout, which makes it a keystone species, so very important to the ecosystem. Importantly, Yellowstone cutthroat trout spawn in the springtime, and they move up into tributaries, which make them accessible to these predatory species at certain times of the year. Importantly, coming off winter when those nutrients are probably really important to those. So this delicate ecosystem balance came under threat with the invasion of lake trout into Yellowstone Lake. And lake trout were discovered in Yellowstone Lake in 1994. They were probably introduced a few years before that. And we know that these fish were introduced from a neighboring lake called Lewis Lake, which is in the vicinity, but from a completely separate drainage. So it was kind of a big deal when we discovered lake trout in Yellowstone Lake. And this is why it was a big deal. These fish are very predatory. They dwell deep in the water column, which means that they're not necessarily an accessible food source for all those species we just listed that rely on cutthroat trout. They can live to be very long. I think one of the oldest specimens is like 60 years old. And they spend their entire life in the lake. So they don't move into tributaries to spawn like cutthroat trout do. They do it all in the lake, and they spawn in the fall. And Yellowstone Lake is like the perfect ecosystem for them, unfortunately. And so in this population, they produce thousands of eggs and readily reproduce. So this is a pretty drastic image of the problem that we're dealing with. When these fish get large, they prey on cutthroat trout, and this specimen here had 3 cutthroat trout in it. Each of those fish is almost a third of the length of the lake trout. So you can imagine at a large scale what this could potentially do to a native cutthroat trout population. And unfortunately, that's exactly what we saw. As the lake trout population increased, over time, the cutthroat trout population decreased. And here we're talking about numbers of spawning cutthroat trout that were observed in tributaries compared to estimated biomass of lake trout in the lake over time. So the Park Service knew that we had to do something. So right away after the discovery, we started gill netting to try and suppress the lake trout. And in the early years, we were still kind of figuring out those dynamics, but we realized later that we really needed to put a lot of effort into gill netting to get on top of this lake trout population. So we hired a contract gill netter. The Hickey Brothers Research is the company that won the contract, and they have been gill netting since 2010. And in 2012 was really when that effort of gill netting ramped up. So this figure shows the different levels of effort that have been put into gill netting throughout the years. So after 2012 was when we really started to put a lot of effort. And the Hickey Brothers run like 5 different crews on Yellowstone Lake at any given time, and they fish from right after ice off in May to October. So overall, 4.8 million lake trout have been removed from Yellowstone Lake, with 240,000 of those removed this year alone. And so we have pretty good population estimates of lake trout run by our great population modelers. They're way smarter than I am and dive into the statistics of this. And one thing that I would like to note, we have this estimated abundance of lake trout through time for the different age classes. And I'm going to start here at the bottom. This was really important, that it's an achievement that we're really proud of, because we have declined these large predatory fish by over 90% since the population's peak in 2012. And so why would that age group in particular be important to target?
For the big ones?
And therefore,
Eat the smaller ones.
exactly, yeah, they're the ones that when they're young, they kind of prey on inverts, and then they switch to eating the cutthroat trout. But why else?
Egg producers?
Yeah, so those are the fish that are sexually mature, and the ones that are going to be contributing more to the population recruitment later. So we're really proud of this achievement. We're also declining the age 3 to 5 fish, but interestingly, our age 2 fish, they're kind of staying relatively stable. So we've been looking at different ways to target these younger classes. Age 2 is the first year that those fish are susceptible to our gill nets, and so they essentially have the run of the land before then. So this is something that we've been looking into, and we're calling this our alternative suppression methods. One really interesting and promising method is the application of carcass or carcass analog pellets to lake trout spawning sites. And this is an attempt to smother the gametes and try to reduce the amount of recruitment that occurs. And so when lake trout spawn in the fall, they spawn in congregated areas in Yellowstone Lake, mostly in rocky areas like this. We have then targeted those spawning areas by applying carcasses or on a large scale carcass analog pellets. And what happens is, as these pellets decay, they create anoxic conditions, which drives dissolved oxygen down to 0, killing the gametes. We did this in 2019 and 2020, kind of on smaller scale sites. And the following spring, we didn't detect any recruitment occurring from those sites. So this is a really promising method, and we have plans to do this again this year. So we're excited to see. It's still in the experimental stage, and we have a lot of studies kind of going into this project. Yeah, so promising. But the bread and butter of our operation is really the gill netting operation. Just like we need to continually do construction to maintain our roads, we need to continually gill net to make sure that lake trout population doesn't go up. Yeah.
Could you just explain what gill netting is?
Yeah, I can absolutely explain what gill netting is. I apologize that I didn't do that. So gill netting is it's a net in Yellowstone Lake. It's a net that sinks to the bottom. It has a lead line and a float line, and there's different sizes of mesh. So if you imagine a net with different sized holes in it. And what happens is it's kind of sitting there in the bottom of the lake, and lake trout will swim into it, and then they kind of get stuck, and then they try to back out, and it gills them around their gill. And so that's how we catch them. And then those nets are pulled up out of the water, and then the lake trout are removed, and then the nets are set back in the water. Yeah. Sorry that I didn't explain that. Mm-hmm. Yeah, so something that we'll have to continually do for the foreseeable future. We are constantly reassessing what threshold we need to target to keep that lake trout population down. We have a lot of other research going on in Yellowstone Lake. We're looking at lake trout reproduction, the different nutrient cycling mechanisms with the carcasses being dumped back into the lake. Food web dynamics from plankton to grizzly bears, juvenile lake trout ecology, so what's happening with lake trout prior to them becoming susceptible to their nets at 2 years old. Cutthroat trout abundance, so we're conducting a tagging study. We don't actually know how many cutthroat trout are in Yellowstone Lake, and so this will be kind of a really important metric that we will have to monitor. And then cutthroat trout genetics. So are there different genetic structures in Yellowstone Lake? Are there different tributaries that cutthroat trout go to spawn to that then contributes to specific populations within Yellowstone? So a lot of research going on in the park. And so you might be asking, like, Andi, what is the status of our target species, the one that we actually care about? And I'm happy to report that the data show we are recovering them. We're really excited. So this figure shows cutthroat trout catch per unit effort on the y-axis, and that is a measure of the number of cutthroat trout per 100 meters of gill nets set for one night. And so kind of a complicated metric, but it's really stems from standard assessment netting that has been conducted within Yellowstone the same way since the 70s. And so we have this really long-term data set, so it's a really important metric for us to measure through time. And you can see when lake trout were discovered in 1994, shortly thereafter, the trout population plummeted. After we began that really intensive gill netting in 2012, we started to see an uptick in our cutthroat trout. And excitingly, we just got the data in a few weeks ago. For 2024, we are hitting right there at 40 cutthroat trout per unit effort. And that horizontal solid line is our primary benchmark to attain, whereas the dashed line is our secondary benchmark. So we're really excited to be at this level. So not only is the scientific data like showing recovery, but we also have a lot of observational data showing this recovery. A team of National Park Service employees, Montana employees, and Wyoming employees went into the most remote region of Yellowstone National Park last year, which is the headwaters of Yellowstone Lake, and we conducted a sampling event up there. And there's a really good article showing what we found in Fly Fisherman magazine, written by Paul Weimer, who was on that trip. And I feel like I'm bragging when I put up this slide because there were so many big and beautiful spawned up colored cutthroat trout in the streams up there. You could see they were actively spawning. We ran into outfitters, so folks who outfit for angling trips, and they had talked about how they stopped going into the thoroughfare when the cutthroat trout population was at its lowest because there were no fish. And now the fishing has never been better. So we're really excited to hear some of that. Oh, I'll also say one really cool thing that happened on that trip is a cutthroat trout that was tagged in Yellowstone Lake the year before was caught in the thoroughfare. And so just distance-wise, that's like 40 miles that cutthroat trout traveled upstream to then get caught by the same people who had tagged it the year prior. That poor fish, he was probably like, I can't get away.
So are those just tagged, they're not GPS, so you can't really,
Correct, yeah. Mm-hmm.
like I know you GPS some of the lake trout to
Yep.
see where their spawning beds are.
Yeah.
You're not doing that with the cutthroat?
Not yet. There have been telemetry studies with cutthroat trout, but we don't currently have any going on right now. So just for the Yellowstone Lake summary, more than 4.8 million lake trout have been killed since 1995. We've reduced the number of adult lake trout by 90%, but the recruitment of those young fish still remains strong. So we're looking at new methods to kind of target those younger fish. And then cutthroat trout are showing really strong signs of recovery. We've documented them in a lot more spawning tributaries that they historically used. And grizzly bears have also returned to eating cutthroat trout in the spring, as have a lot of other species. So, these are all great signs of ecosystem recovery. And now I'm going to kind of dive into Yellowstone cutthroat trout, but outside of the Yellowstone Lake watershed. We're going to talk about cutthroat trout in the Lamar River watershed, which faces non-native threats, but of a different species. Hybridization with rainbow trout is the main threat that Yellowstone cutthroat trout in this drainage are facing, as well as competition with brook trout. And I'll get into some of that here shortly. One other threat that's always kind of on the back of our minds is the introduction of potentially new non-native invasives. So a few years ago, smallmouth bass were found at the very edge of Yellowstone National Park. And so this is something we're pretty worried about because smallmouth bass, like lake trout, are a very predatory riverine species that could decimate our cutthroat trout populations if they were to get in the system. So how do we manage for things like hybridization and brook trout? One of the things that we focus on is barrier exclusion. So this includes isolating populations to prevent non-native fish from downstream continually infiltrating the genetically pure populations and causing additional hybridization. Paired with that, we can do selective removals. We have done a pretty dang good job recently of using our fly fishing volunteer program, and must-kill angling regulations are actually a really effective tool as well to target non-native and hybrid trout in this watershed. And we also conduct annual electrofishing to remove these hybrids. A more aggressive approach we can take is the use of chemical removal. So there's a chemical called rotenone that is a fish toxin that we can apply to the water and kill all the existing fish in that water. And we have applied this consistently throughout waters in Yellowstone for the last 20 years with great success. Elk Creek and Soda Butte Creek, and we have plans for future projects to use this chemical as well. After chemical treatment, we can either put back in fish that were salvaged prior to treatment or new genetically pure strains. So Buffalo Creek is an area that we have not done a chemical treatment on yet, but we hope to in the future. And this figure on the on the right shows the problem. Buffalo Creek is a source of hybrid fish in the watershed. And so the dark red circles are fish samples that were more hybridized, whereas the light yellow were genetically pure cutthroat trout samples. So we know that this creek is a problem source for the Lamar watershed. And so we are hoping to get in there and really tackle that system and remove hybrids from them. Soda Butte Creek is another project. This stream flows through Cook City, Montana, and into the park. Soda Butte Creek was actually treated several years ago in 2016, and we did a project to remove brook trout, which are really good at moving into a watershed and out-competing cutthroat and just pushing them out of the system. And so we tackled that in 2016. But unfortunately, after the historic floods of 2022, we rediscovered brook trout in that watershed. At this time, we don't know how they got there, but we did know that we needed to do a treatment shortly thereafter, or those fish would spawn and create more brook trout. So we got right on it and treated that system again last year. We salvaged cutthroat trout first and then put them back in the watershed. And moving forward, we'll be doing eDNA monitoring to make sure that there are no more brook trout in there. This is my boss here on the right, and all of our bosses here on the left. Dr. Todd Kuhl is the head of the fisheries program, and Mr. Cam Shawley is the superintendent of Yellowstone National Park. So I'm going to have you direct any hard questions to them, but I'll take any easy questions today. Yeah.
How many biologists work under the director?
Todd, so there's 5 of us. So I'm one of 5, and we have 2 streams biologists. I do cutthroat on Westslope and Arctic grayling, and then we have another streams biologist that does Yellowstone, and then the rest of our bios are on Yellowstone Lake.
So I've heard a lot about that Yellowstone volunteer fishing program, but I can't find anything on how we can become a part of it.
I am going to get you that information at the end of this slide, or at the end of my presentation.
Okay.
Yep. Mm-hmm. Yeah.
Do you have any idea how the lake trout was introduced to Yellowstone?
Yeah. We suspect there are a few different hypotheses on how that happened. The most likely is that they were illegally moved from Lewis Lake to Yellowstone Lake. The watershed is technically connected in the thoroughfare region, but the trout from Lewis Lake would have had to exhibit odd behavior swimming upstream, which lake trout don't normally do, and would have had to come around to Yellowstone Lake, and a lot of them would have had to do it. There are some hypotheses that helicopters scooped water out of Lewis Lake and dumped them in surrounding areas during the 1988 fires, where a large majority of the park burned. So there are different hypotheses, but yeah.
You also said that there was a study for cutthroat, like the cutthroat abundance, to monitor. How does one do that?
Yeah, that's a great question. So we, to study cutthroat trout abundance, we are conducting a mark recapture study. And so what happens is, you saw that fish was tagged in the thoroughfare. So we do a pretty immense tagging effort throughout the season. And then the number of fish that are recaptured allows us to it tells us our proportion of capture efficiency, and that will all contribute to a population estimate. Yeah, in its most rudimentary form. So, yeah. Mm-hmm.
As cutthroat numbers increase, are you catching more of those in your lake trout sets, and how are you avoiding that?
Yeah, our gillnet netters are incredibly proficient at avoiding catching cutthroat trout. There does tend to be some bycatch, but through time they've actually become more skilled, and so our bycatch is actually staying the same or going down despite an increase in effort. And so that's really due to the skill of our contract netters. There is some level of overlap, but in midsummer, because of that thermal separation where lake trout are deep and cutthroat trout remain higher in the water column in warmer water, we can mostly avoid that.
And just like some people had questions about what the gill netting is, can you describe some of the barriers that you use to prevent those fish from getting in different tributaries?
Absolutely. So barrier technology has come a long way since we first started using this, but the park uses different types of barriers. So we can modify waterfall by blasting it with dynamite and create like an actual like barrier that's tall enough where fish can't get over. That's one method. We have built concrete barriers with splash pads so that there's a very clear drop and then a splash pad so fish couldn't hang out in a pool and get momentum to jump up. And we've also built barriers using logs and just more natural materials like that. So yeah, a lot of different ones.
How much disturbance does the gill netting cause to the bed of the lake, and are you worried about it?
To the bottom of the lake?
Yeah.
We're not worried about it. There's another method of netting called trawling, which would be way more detrimental to the system, but the nets essentially just get dropped down and then they just get picked straight back up. And so there's not a lot of entanglement with the benthic regions. There can be more entanglement if the nets are dragged at all, but again, our contract netters are very skilled, and so they just pick them straight up. And there are some like kind of thermal feature areas that our crews avoid to not disturb those areas.
And then obviously the Lamar area, the northern range, was affected greatly during the floods. Have you done any studies? How do you feel like the fish have been affected because of the floods? Rivers are rerouted, beds that they would, pools that they would be in, everything has been kind of disturbed.
Yeah.
How do you feel like that's changed?
Yeah. We're still kind of figuring some of that out in our sampling. So we did notice like the 2022 year class is kind of lost. There aren't very many of that size of fish. And generally kind of fewer fish throughout the system. But the fish that are there are really healthy, probably because there's fewer of them. There's more resources for them to get into. But yeah, and what you're saying with the habitat, it really has changed quite a bit. And so to see how that looks moving into the future, we're still kind of figuring out. Yeah.
You commented on how the evidence seems to show that the cutthroat population is greatly up in the Yellowstone Lake itself. Anecdotal evidence suggests it's really up in the thoroughfare region. Do you have any anecdotal evidence on spawning downstream of Yellowstone Lake?
Yeah, we don't have annual sampling there. Personal experience fishing there, it's very good. I was actually really excited to see this, but this year in the section downstream of Yellowstone Lake, there were thousands of really small cutthroat trout that were recruited from last year, and they were everywhere. I haven't seen anything like it. So yeah, anecdotally, I think it's going to be really good. One more question, then we'll move on.
And do you have any idea how much this whole project has cost?
Yes. Yellowstone Forever, so generous. And this, what are we up to? Do you know? This is a question for my boss. But I think we spend close to $3 million a year between the gill netting operations and everything going on in Yellowstone Lake.
Since when have you been doing that?
Well, it hasn't always been that expensive. Yeah. Mm-hmm. Okay. All right, we're going to move on, but more time for questions about everything at the end. So Westslope and Arctic grayling, this is my bread and butter. This is what my crew and I have been doing for the past few years. Westslope and Arctic grayling are native to the Gallatin and Madison River drainages in northwest Yellowstone National Park. A lot of people don't realize that we have the Madison and Gallatin River drainage at headwaters in our boundary. And Westslope and Arctic grayling were native to those drainages, but similarly, by the turn of the century, there were hardly any genetically pure cutthroat trout left in the system due to hybridization with both rainbow trout and Yellowstone cutthroat trout, which is interesting because Yellowstone cutthroat trout were also stocked before managers knew back in the day that they were subspecies, not genetically distinct species. And then Arctic grayling became completely extirpated from Yellowstone National Park waters. So in 2010, the Park Service set a pretty achievable, or I guess a pretty prestigious goal to sample or to restore cutthroat trout and Arctic grayling to 20% of their historic range within park waters. And so how do we go about doing a restoration when you don't have any genetically pure fish left? What we did was we did a similar to the Lamar Valley. We set and made barriers and then chemically treated waters upstream of those barriers with rotenone to remove all the non-native fish that were in the system, and then translocate genetically pure fish back to that water. And so I'm going to kind of dive into the Upper Gibbon River watershed, which is our most recent project. All the projects we've completed are highlighted in the dark purple, and potential future projects are kind of the lighter purple. So the Upper Gibbon River is the headwaters of the Madison River drainage, and it contained non-native rainbow trout and a non-native population of Arctic grayling as well. And we treated this watershed in 2017, and it included 3 lakes and about 11 miles of stream. And there were natural waterfall barriers on this system, which made it nice. We didn't have to do any blasting on this one. After the treatment, we stocked both Westslope cutthroat trout and Arctic grayling back into the watershed. And when we go to stockfish, this is a little bit of what that looks like. These are Arctic grayling fry that we spawned from a local source in Montana. And then we brought those fish to a hatchery, and they raised them to this fry stage for us. And after they got big enough, we put them in coolers and threw them on our backs and hiked them 3 miles into the backcountry and released them into their new habitat. And they were very, very happy little fry to be out of that cooler. And really excitingly, when we went to go do this, we found naturally reproduced Arctic grayling in the same area when we went to stock these fish. So we were really excited to see that. And so the system has both lakes and rivers, which are monitored differently because of their different habitat types. And so this figure on the left shows the riverine habitat sampling. And so this is the number of fish caught and then the frequency of those fish caught in a certain total length, highlighted here in millimeters. And so Westslope cutthroat trout are in gray and Arctic grayling are in blue. And there were plenty of small Westslope cutthroat trout, so we're really excited to see that in the stream. We also saw fry. We know Westslope cutthroat trout are naturally reproducing in this watershed. Sampling lakes in the system was a little bit trickier. We have other species of native birds that we have to be considerate of. So normally we would set nets, like gill nets, like we do in Yellowstone Lake, to do sampling in other systems as well. But if we were to set gill nets in these systems, we would probably accidentally kill some of our native bird species that dive in the water, and we just can't afford to do that at this time. And so we were really limited in the number of sampling that we could do in our lakes. But we did do some angling, and as you can see, we got some fish. But again, it was really limited. So we really decided to make a concerted effort in 2024, and we used our volunteer fly fishing program to target the lakes. And we were really successful at doing this. We had 8 volunteers come in 2 different time periods, and they fished for 4 days straight. And we caught an immense number of fish. This is over 600 fish caught between the 2 groups. And really, the data that we got from this, we just really wouldn't have been able to do without expertise fly fishing fishers coming in to help us. And so I'm just so thankful for that program and that we were able to do this. And these are just some results. So again, this is a link frequency graph. Grebe Lake is on top, Wolf Lake is on bottom. Grebe Lake has a lot of really large cutthroat trout in the system. It is a beautiful fishery. Wolf Lake had fish that were quite a bit smaller, but catch rates were quite a bit higher as well in that system. So we were having really great days, sometimes 100 fish days in there. And importantly, approximately 9% of the grayling, or of the fish we captured, were Arctic grayling. And so that's really important for me to know, because I think we would like to get those numbers a little bit higher. So looking to the future, we'll probably do more continued stocking to see if we can't boost that number a little bit. Similar to Yellowstone Lake, we have seen a really cool observational data of there being a lot of bird species that are probably using these fish as a food source. And so this is just some of the ones that we observed in the area while we were there. And we did watch an osprey scoop a fish out of Wolf Lake while we were there. So it's really exciting stuff to see. We were also tagging these fish, so we were doing a mark recapture study in this system as well, and so that fish has a little bit of a flow tag going on. And this is an Arctic grayling in Ice Lake. Ice Lake is really close to the road, and it has a really great population of Arctic grayling. We only stocked Arctic grayling in this system, and they are doing really well there. So we're pretty excited to have this resource so close and available to the public, because it's only a quarter-mile walk from the road to get there. And so in summary, for our Westslope cutthroat trout restoration progress, we set that goal of 20%, and in the Gallatin River watershed, we're about halfway there of achieving that goal. And if we do one more project in that watershed, we'll get close to attaining our goal of 20%, or we'll surpass it. And then in the Madison River watershed with the Gibbon River and Grayling Creek projects, we have surpassed our goal of 20%. We're at 22%, but that doesn't mean we're gonna just stop and leave it as is. We want to continue restoring these streams back to their native species. So if anyone has any questions about Westslope or Arctic grayling, would love to hear them. Yeah.
You mentioned that the grayling population was made up like 9%, and you wanted to see it go up. Like, what's the ideal ratio that you would like to see?
Yeah, that's a good question. That's not something I have thought about. I feel like when I know it, I'll see it. But yeah, you're right. I should maybe kind of look at historic numbers and see what their cohabitation rate with Westslope and Arctic grayling was, and see what's achievable. Yeah, thank you.
That kind of is why I was just curious, what historic data do you have? How do you know what
we don't have a lot of historic data on Arctic grayling. I haven't come across hard data, not in Yellowstone National Park. There could be data in other drainages that I could look into. So, yeah.
They weren't known east of the
divide? This is east of the divide. The Madison and Gallatin River drainages are east of the divide, which is a little bit confusing. But there are grayling. There are not grayling on the west side of the Continental Divide in Montana. It's just the upper Missouri River drainage. So.
Was the source of your grayling eggs from a fluvial system, or was it from a lake system?
It was a fluvial system. So the Big Hole River fish are what we took from, which is the last fluvial grayling population in Montana that has fish to do. And we didn't take from the wild population. We took from a brood source that was established from the Big Hole population. So, yeah, and so this is getting back to adfluvial, which are lake-dwelling grayling, versus fluvial grayling. There's been some arguments about, what would be the best genetic strain to put in the system. And we ultimately wanted fluvial fish in there because we want them to inhabit the Gibbon River. Any other questions? Yeah.
So you mentioned your question, how do you create a pure strand from hybridized strands? What kind of isolation methods does that take to kind of bring them all back to?
So I think you're asking, once it's hybridized, how do you get it back to pure? if you isolate. One method that we could do is called genetic swamping, where we have, some level of hybridization. We isolate and cut off the hybrids that are more, the non-natives downstream, and then we can stock more genetically pure fish to just add the number of pure alleles to that population to try and cut off, or swamp out. We call it genetically swamping out the number of hybrids.
I got a question about the chemical removal of fish. So how does the rotenone not kill off all the fish?
It does. So it targets all gill-breathing organisms, and so we apply it to a system, and then it will kill everything that's exposed to it. We have very controlled ways of doing this through drip stations where we're applying just the exact amount we need to kill fish. And so when we do a salvage, we would go in and remove fish first, and then any fish that are left would get killed. But that compound degrades very quickly in the water, and so we actually have to keep reapplying it to keep it effective at killing fish. And then at the bottom of like a treatment area, we would neutralize that chemical with another chemical called potassium permanganate. And so we don't, that way we can control where the chemical is at all times, and it won't get past us downstream and kill something that we don't want it to. All right. We're going to move on to kind of the end of this presentation here, and I'll just quickly talk about our fly fishing program, our aquatic invasive species program, and some regulation changes. So this is the gentleman that you need to get in touch with. This is Mr. Paul Weimer. He'd be mad if he knew I said this, but he's kind of a big deal in the angling world and in the bug world. He has like 3 different bug books, and a very knowledgeable guy about fly fishing. And our 2024 volunteer opportunities are done for the summer. We don't have anyone volunteering in the park right now, but that email is how you can get in touch with him, and he'll give you instructions on how to volunteer for 2025. So that's volunteerflyfishing@yellowstone.org. Yeah, and this year alone, we had 65 volunteers that were here over 8 weeks and landed just over 950 fish in the season. So yeah, pretty impressive stat that I hope we can beat in 2025. Our aquatic invasive species program, this is something that we've really ramped up in the last few years with the hiring of a lead for this program, Mr. Mike Canetta. And some of the goals of this program are to prevent aquatic invasive species, detect any potential new aquatic invasives that become established in Yellowstone, and then also monitor the ones that we do have here. Another big part of this program is to educate folks on how to not spread AIS. So what's the mantra that we hear from everybody? Clean, drain, dry. So make sure any watercraft, waders, flotation tubes, anything that you're putting from one water body into another, make sure it's clean, it's drained out, and it's dry. We are taking a very proactive prevention approach. Yellowstone has so many different headwater streams in the park that it's so important that we keep AIS out of these systems. Specifically, zebra and quagga mussels are of great concern because they've been encroaching closer and closer to the west as time goes on. And we have mandatory inspections that have to be done before any watercraft or flotation tubes can be deployed in Yellowstone. This year we've done over 3,400 inspections. And then also new this year, we implemented a 30-day dry time regulation where sailboats and certain types of motorized boats have to be dry and out of the water for 30 days. And this includes inboards, boats, inboard outboard boats, so the IO boats, not outboard boats to be confused, and then inboard jets and sailboats. So just something to be aware of if you're planning to boat in Yellowstone. If you have one of these types of boats, you have to have proof that it's been dry for 30 days before it can launch in the park. And also new this year, we have permanently prohibited any boats that have been or that are or have been previously mussel fouled, regardless of dry time or decontamination. We just feel that it just poses too much of a risk to our monitoring, and we just don't want to risk it. And we've also banned ballast tanks, so contained ballast tanks in boats, and that's not new this year. It's been a regulation for a few years now, and we also are not allowed to use felt-soled wading boots in Yellowstone. So, and all these regulations are aimed at preventing, the movement of AIS and the risks associated with them. Also new this year, historically, our angling season has been from May to October. New this year, we have opened up 2 streams to year-round fishing, and this includes right here by Gardner, the Gardner River, which is now open to year-round fishing from Osprey Falls down to the Yellowstone River confluence, as well as the Madison River from the Wyoming state line to the Yellowstone National Park border. And this is just to provide more opportunities and be more in line with our local Montana state regulations or opportunities. If you do go fishing in Yellowstone and you catch a tagged fish, please report it to us. We have a lot of tagged fish out there. A lot of people accidentally get a picture of the number, or the phone number, but not the tag number. If you want information on your fish, like when it was tagged, who tagged it, and any other information about that, we need that individual tag number, and that's really important. That helps us estimate population size. It gives us survival statistics and movement statistics, like all really important stuff. So we found some really cool things where fish have moved a long ways, and we had no idea that they would do that. So. Please report your tagged fish. And I have to give a special thanks to my crew in the back. You guys raise your hands real quick. Jonathan, Reagan, and Megan are all on my fisheries crew, and really the backbone of what our fisheries program is. We could not do what we do without the support of our seasonals. And for those of you in the front who are potentially looking for some summer gigs, those would be a couple of great people to talk to about how to get into this program. And I also just have to extend such a thanks to Yellowstone Forever. Such a huge support of our program, not just financially, but, in every way. And we couldn't do what we do without your help. So with that, I would love to take any final questions you have. Yeah.
A couple of questions. So on the new fishing regulations as far as year-round fishing, especially the one on the Madison, or is there going to be new border markers that are going to tell us when we hit that Wyoming state line? And who's going to regulate that?
Yeah.
Since it's gonna be year-round?
Yeah, so it'll be regulated like it is now, with rangers patrolling and asking for permits. As far as if there's a boundary marker, I know is there a Wyoming state line marker?
On the road.
Yeah.
But
not right there at the stream. Yeah, it could be something. I'm not sure if that's the plan or not, but yeah, it could be something where we have a little post and informational sign right there in the stream.
Yeah.
So, yeah.
And then, as a kayak lover and water lover as well, I think you guys are doing a great job. I do think that you can take a little page out of what Tetons is doing. They're very strict. And I come into the park hundreds of times every year with my kayaks, and I've never had anybody question or give me information on what I can do with my kayaks in the park. But when you go to the Tetons, you can't even get into the park without your boat being checked. I think that you guys can do a better job at the gates, if nothing else, if not boat checks, information
Yeah.
in your pamphlets,
Yeah.
because I do agree, it's very important to protect our waters, and I feel like we can just take it to the next level and be more diligent. in
Yeah.
protecting the waters.
I will absolutely pass this on to Mike Canetta, the head of our AIS program. He came from Tetons and has experience working there, so is very familiar. And yeah, I will absolutely pass this on. And I agree. If there's a way to potentially catch things coming in earlier than by the time they're at Yellowstone Lake or at Bridge, or at Lewis Lake, it'd be something good.
I'm shocked that more people don't try to throw their boats in the Madison or in Yellowstone. Because, I mean, who's educating them to tell them they can't?
Yeah, it does happen,
I
and
know.
it does happen. And the rangers are very diligent, and do a great job of catching that sort of illegal activity. So, yeah, thank you. Yeah.
I was curious about the methods of the delivery and the kind of search for lake trout nesting sites and how you deliver the.
Oh yeah. Okay. So first off, we find lake trout spawning sites by putting tags in lake trout and then releasing them and tracking them back to those spawning grounds, which is a really cool technique in and of itself. And then once we have these spawning grounds mapped out, we actually use helicopters to drop the pellets, and so we have a seeder. So it's a big container that holds all the pellets, and it just kind of spreads them out in a uniform way, so that we get complete coverage over the area. So yeah, it's 40,000 pounds of pellets that we drop on. That we're planning to drop in a couple weeks, and so yeah, we can't do that on a boat; it would sink. So yeah, we have a helicopter doing it in multiple loads.
So the pellets will sink and they'll stay in water will move them?
No, they're formulated such that they soak up the water and sink down. And they're made of wheat or soy and gluten. I don't know the exact components of it, but yeah, they sink, and then they're there for a while, and then they kind of dissipate, and the wind does push them around eventually. But in the past, we've been able to get enough of a coverage for long enough exposure that it kills the lake trout embryos.
So I know in the past you actually use the dead lake trout bodies and carcasses to drop on those beds. You're using the pellets now, but they don't have any lake trout info in them?
Correct. So yeah, it's a totally different one. So we started this out, this has been a few years in the making, so we did start it out using lake trout carcasses themselves. So we started out laying out whole carcasses, but then bears kind of came in and decided that they wanted to eat those carcasses. And we also weren't, I don't think, getting quite the coverage that we wanted with the carcass material falling into the interstitial spaces of the spawning habitat. So then we moved to getting lake trout carcasses and grinding them up in like a wood chipper style thing, like straight out of Fargo the movie. And then we laid down ground carcass material and that I think that was working well as well. But then the problem becomes we have to do this in such a short period of time, and we need such a large amount to do this on a whole island. We need additional material, and so that's when we moved to the carcass pellets analogs. Yeah.
How large are these spawning areas?
It depends on the spawning area. I wish I had the exact acreage for you, but Carrington Island, probably from here, the size of the room, but then the very edge of the margins of the rocky substrate where lake trout would spawn might extend further. So yeah, I don't have the exact amount, but compared to the rest of Yellowstone Lake, it's really a small size. So we're feeling, confident that if this method really works, we could potentially eliminate recruitment from some of these biggest, best spawning areas, which would be huge.
Do you have to be careful with the nutrient cycle of the lake when you dump all this stuff in?
Yeah, this is something that we've been monitoring very extensively, and we have not detected any adverse effects from adding nutrients to the lake. So this is something we don't want to cause any potential, unwanted consequences, and so we have all sorts of studies set up to do this each time we add in nutrients to the system. Mm-hmm.
That's why you also don't take the carcasses out of the system.
Yeah, we keep the carcasses in to recycle them, so the nutrients stay within the watershed. Mm-hmm.
Could you just repeat that volunteer email?
Yeah, why don't I pull it up right now? There it is. So volunteer fly fishing at Yellowstone.org, and it's Paul Weimer. You tell him Andi sent you, and if he, and then you can, and then you can call me if he refuses.
It's in the second line.
Well, folks, if I'll take one more question if there is one. Great. Yeah.
What's the favorite thing about your job?
Man, this is such a hard question. I think that I really enjoy being able to hold an organism that is kind of, cryptic. It hangs out on the water. Not everybody gets to see it. I think that's one of the most special things about what I do. And I would say more recently, too, it's been such a privilege to mentor and see other employees kind of move through this process and start to see their first, hold their first fish that they caught on a fly for the first time. And so that's been a really rewarding part of what I've been doing as well. So, yeah. Thank you for that. And I will say since I have a lot of students in the room, we hire seasonals, and the announcement for our seasonal positions will open up in probably November, December-ish. And we hire 6-month positions, and we also hire intern positions. And so our 6-month positions will be advertised through usajobs.gov. And then our intern positions will be advertised through the Student Conservation Association. And Megan, I have your email, so I can send you that information. Yeah. Are there any seniors in the room? Nice. Yeah. Great. Yeah.
When does the internship also go 6 months, or is that a shorter term?
There are 2 terms, so we hire from May to August, and then from August to October, so 2 positions. So yeah. Yeah, Reagan is our SCA right now, and Reagan is going back to school this fall. So that's kind of nice that these are designed so that students can go back to school. Yeah. Okay, I think that's all. Folks, thank you so much. I appreciate it.